Good afternoon. By names of Tangela Debra. I'm in the subgroup 3. We have discussed about solar radiations. We will see in this topic meaning of solar radiation, and we will see interactive questions, sun transmission of energy process, importance of solar radiation in crops, basic radiation laws, solar spectrum, and we will see the answer of some question we have asked in interactive questions, and we'll see conclusion and reference. So let us start by the definition of solar radiation. It is the energy emitted by the sun in the form of radiation, which are electromagnetic wave. It is primary source of energy on the earth. It is also defined as a flux of radiant energy from the earth. Most life depend on solar radiations. Most of organisms live on the earth. Their life depend on solar radiations. The most visible of solar radiation is light. Our sun emits mostly white light, which is a combination of various wavelengths. Light is a combination of different colors such as red, orange, green, etc. All those that our brain interpret as color white. So let us move on. So solar radiation, it combines or tell us about how the light rays comes from the sun and then reach to the earth. As some rays reach to the earth and then reflect back to the atmosphere. Here we have the picture or the image shows or demonstrates how solar radiation acts. Here we see the sun and some rays which is focused on the earth or which is point to the earth, and another which is reflected from the earth. Some solar radiation is reflected by the earth and the atmosphere. Those rays point to the earth are those which is reach to the people or reach to the organisms, living organisms. So let us move on interactive questions. In this topic we have some question. What types of solar radiation? Are solar radiation mostly needed by plants? What are transmission of energy processes? Which one is the kickoff laws? We will see the laws of solar radiation. We will see those laws. Which one? Diameter of the sun can be given as we will find what the diameter of the sun, and then we see the energy radiated from the sun is visible region will be allowed. We'll see the percentage. You can ask yourself what percentage the energy or the rays of the sun reach to the earth. Then we will see the value of solar constant can be given as we will see the constant of solar. You can ask yourself what is the constant of solar. We'll see. Then we have temperature on the sun is around. You can ask yourself what temperature of the sun. Okay. Then let us move on first on the sun. So, Sun is a star at the center of the solar system. Sun looks like a star at the center of a solar system. Then, the origin of radiation that reaches the Earth is the Sun. The origin of the solar radiation is the Sun, because it is the one who which gives the light rays. The main features of the Sun forms the nucleus of the solar system. All the planets revolve around the Sun. Yes, everything, all the Earth is moving around the Sun. Sun is not moving, but Earth is moving or revolving around the Sun. It is a mean distance of it, it is at a mean distance of 150 million kilometers. It is a diameter is 13,092,000 kilometers. The diameter of Earth is 12,756 kilometers. Its volume is approximately 1.3 million times more than the Earth. It weighs more than 3,000 times much as the Earth. It takes 8 minutes 2 seconds for its rays to reach the Earth. It's bigger the Earth 109 times in the diameter of the Earth. So let us move on. The solar surface is composed of 3 gaseous layers. The innermost surface layer is called photosphere, and its temperature is about 6,000 Celsius. The middle surface layer is called the chromosphere, and its temperature is about 5,000 Celsius. The outer surface layer is called the corona. Here I have some picture which demonstrates the layers of Sun. Here we have corona, we have chromosphere, and even photosphere. Then let us move on the processes of transmissions of energy. We are going to see how the energy is transmitted, how it is transmitted from the source or from the origin to the another objects. It is transmitted by 3 processes, which is conduction, convection, and radiations. Let us start on conduction. Conduction is a transfer of heat from one substance to another due to the direct contact. For example, is the iron and the clothes. When we are ironing the clothes, the heat is transmitted directly from iron and then it goes to the clothes. Those here we have a picture which shows the how conduction process work or act. Here we have the person who are in a chicken, and here with a saucepan on gas cooker. Those heat is transferred or is moved from the gas to the saucepan, which means they go to the direct contact, happen the direct contact, which means the heat is transferred from one object to another, go to the direct contact happened. Next one is the radiation. Radiation is a process of transmission of energy from a body to another without the aid of material or medium, which is solid, liquid, gas, etc. Solar radiation, solar radiation is heat is transmitted from one object to another through rays. It is not a direct contact or transmission happened which is nearby. It is from the source to the next object by rays. Here we have an example. These are heat or fire which is on, and here are some hands near. Those hands gain the energy or gains the heat from the fire by rays. Those heat, it is not come from the source directly and then reach to the hand. It reaches to the hand by rays. For example, when it's like how the sunrise rays reach to the people. It reaches to the people by the forms of radiations. Let us move on to convection process. It is a process by which heat is transferred by movement of heated fluid such as air or water. So convection process is a heat when they happen the mixture of some fluids or some air which is hot and cold mixed, then sharing the cold and heat. Those are convection. For example, it's like clouds. Those clouds which is hot mixed with the clouds which is cold, and then make convection process. Let us move on. No impacts of solar radiation on the Earth's surface. So we have seen how the solar radiation is, how solar radiation act. We have seen the definition of solar radiation, and how we are going to see the impacts of solar radiation on the Earth's surface. Firstly is renewable energy. Solar energy, which is a conversion of solar radiation into electricity heat. It is a rapidly growing source of renewable energy that can help reduce reliance on fossil fuel and reduce the impact of human activities. I think it is understandable. Then another impact of solar radiation is the atmospheric effect. Solar radiation interacts with the Earth's atmosphere, driving various atmospheric processes such as formation of clouds, wind patterns, which is the formation of precipitation. Due to the solar radiations, those solar radiations or solar rays which is reflected from the earth and back to atmosphere, those involves in the formation of clouds which enhance the formation of precipitation or formation of rainfall to the earth. Those rays will make the clouds will make the clouds which will result in the formation of rainfall to the earth. And that is the ultraviolet radiation. Exposure of UV radiation can have both positive and negative effect on living organisms. It can stimulate the production of vitamin D in the human body, and can the positive effect of solar radiation is it brings or to provide vitamin D. Those rays consist of vitamin D to the human body, and the negative impact to the human body can read skin damage, risk of skin cancer, etc. So it have both positive and negative effect. So importance of solar radiation on crops. First law is photosynthesis. By solar radiation, the process by which plants convert carbon dioxide and water into glucose and oxygen. So solar or sun can help the plant.
Hello everyone, my name is Nabanganyimana Radamo. I'm the one worked on this point that I called solar radiation. I'm going to continue about the importance of solar radiation on the crop. For photosynthesis by solar radiation, the processes by which plants convert carbon dioxide and water into glucose and oxygen. Another there is plant growth and development. By solar radiation determine the plant growth and development such as stem elongation, leaf expansion, flowering and fruits production. Hello everyone, my name is Nabanganyimana Randamo. I'm in this group. I'm one that worked about the solar radiation. We have seen that there is a different meaning of solar radiation as we have seen in the previous slide, and I'm going to continue about the different impact of solar radiation on the crop. We can say transpiration. The solar radiation drive the process of transmission where plants lose water through their stomata or their leaves. We know that the transpiration and photosynthesis also taking place on the leaves. It supports plant in regulating plant temperature and uptake of water and nutrient from the soil. We can say crop quality. Solar radiation it has a greater role and it is used to determine the color nutrient that contained in the plant. I think those. Then we have different laws that are related to the solar radiation. The first law is also called Kirchhoff law. He said that a good absorber of radiation is a good emitter in the similar circumstance. This law states that the absorptivity of an object for radiation of a specific wavelength is equal to its emissivity for the same wavelength. The second law is Stefan Boltzmann law, where says that the intensity of radiation emitted by a radiating body is directly proportional to the 4th power of the absolute temperature of that body. Here there is the equation of that law saying that A and lambda equal to emissivity and D lambda, where this lambda means that there is some kind of shortest wavelength. The last law that is related to the solar radiation is also called the Planck's constant. It's also saying that the electromagnetic radiation energy of each quantum is proportional to the frequency, where we have the equation of those Planck's constant law. Energy is equal to nhv, where n means that there is the single number of the photon, and this h meaning that there is the Planck's constant that are equal to this, and where this v is equal to the frequency, we know that the frequency is equal to c over lambda, where c meaning that the speed of light equal to 3 times 10 power 8 meter per second, and the lambda meaning that there is the shortest wavelength. Let me continue about the tools that are used to measure the solar radiation. The first tool is also called pyranometer. This tool is used to measure the total hemisphere radiation on a horizontal surface. Another is also called photoelectric sunshine recorder. This tool is used for measuring varying radiation's intensity. Another one is also called calorimeter or silicon cell pyranometer. It is used to measure the flow of radiation using the photovoltaic effect. Another is also called pyrheliometer. This tool is used to measure direct beam radiation at normal incident, meaning that these rays are also passing into 90 degrees because it grazes into the normal incidence. Another, we have seen that there is the solar spectrum. Let me continue about the solar spectrum, the explanation of electromagnetic spectrum and the solar energy. The electromagnetic spectrum contains all forms of electromagnetic radiation. It's also ranging from the higher energy, that's also called gamma rays, to the low energy, that's also called the radio wave. Solar energy, it also consists the visible light, ultraviolet radiation, and infrared radiation that's emitted by the sun. Now that those type of solar radiation are also coming from the sun. Without sun, we cannot have those type of solar radiation. When the solar radiation reaches to the Earth's surface or the Earth's atmosphere, it interacts with the different gases, particles before reaching to the surface. Let me continue about the factors of solar radiation. We have sunshine time. The more sunshine also represents the more solar radiation. You know that the sunshine is the amount of those solar radiation, meaning that if sunshine is more, the solar radiation is also more. Another is also called altitude. As the altitude decreased, the intensity of solar radiation decreasing, and when the altitude reduces, the solar radiation increasing. Another is also called geographic latitude. At higher latitude, the angle of solar radiation is low and causing that the energy to spread over an area. It is another, I can say, air quantity. Some those air like air pollution can reduce atmospheric transparency and affect total radiation that are reaching and absorb the solar radiation that are reaching to the Earth's surface. And the last is also called atmospheric transparency. The atmosphere reduce of the energy reaching to the surface. As you know that the atmosphere consists of those gases, like those mixture of gases like carbon dioxide, nitrogen, and those it can reduce the solar radiation that are reaching to the Earth surface. Another, you can say, the visible light, that visible light are not the factor that influence the solar radiation. It is another term that I'm going to explain. The visible light is a portion of solar radiation that is visible to the human eye and is responsible for illuminating our surrounding. Ultraviolet radiation has shorter wavelength than visible light and can cause sunburn, but it also needed for the process like vitamin D synthesis in the human from the sun. Infrared radiation has a longer wavelength than visible light, which means that it has less impact to the upper surface of the human body. These are the image of the solar spectrum. There is a portion or aggregate of the ultraviolet radiation, and there is a visible, there is infrared, and we have the another part of temperature that are called black body, and we know that the black body is the body that can receive radiation and emit it, while we have the perfect black body, it is the body that can receive the radiation but without emit it. Then we have the type of solar radiation. It is 3 type of solar radiation. The first is infrared radiation. This radiation provide heat and represent 49% of solar radiation. The second is visible ray. It also represents 43% of solar radiation and provide light. And there is another type that we call ultraviolet. It is the solar radiation that represents the 7% of solar radiation. There is another term that I can add here, that is insolation, is incoming solar radiation, and it also consists of a band of radiant energy of different wavelength. Here there is an interactive question answers, as we have said in the previous slide. There is the question 1 and with its answers. What are type of solar radiation? As we have seen, there is 3 types of solar radiation. The first is infrared, the second is visible rays, the third is ultraviolet rays, where infrared consists 49% of solar radiation, and where ultraviolet consists 43% of those solar radiation and it can provide light. And another one remaining, we have seen that it is also called ultraviolet, that represents the 7% of solar radiation. The second question was asked, are solar radiation mostly needed by plant? The answer is true, because it's also needed by the plant through the process of photosynthesis and in another way. The third question, what are emission of energy processes? There are 3 processes. The first is radiation, convection, and conduction. The fourth question was asked, which one is the Kirchhoff law? As you have seen, that we have A and B, and the true answer here is A, because the Kirchhoff law is saying that a good absorber radiation is the one that the first good emitter. The following is the diameter of Sun can be given. We know that the diameter of the Sun is also called around 1.39 times 10 power 6. Question 6, the energy radiated from the Sun in visible light, you have seen that they are also around 43%. Question number 6, you know that the value of solar constant can be given as 1,367 watts per meter square. And the last question is also called the temperature of Sun is around 66,000 Kelvin as the temperature. So by conclusion, we have seen that there is some meaning of solar radiation, where it is the energy emitted by the Sun in the form of radiation, which are electromagnetic wave. And we have seen that it is also classified into 3 types of those solar radiation, such as visible rays, ultraviolet, and infrared. And those type of solar radiation, we have seen that the visible rays, it have some percentage, and ultraviolet has its own percentage, and infrared has its own percentage, and we can conserve them because it reduces some greenhouse gases emission in the atmosphere, because it harnesses the power of sun energy with a little to no gases being released in our atmosphere. Thank you for your kind attention. God bless you.